This is just a refresh. How many of you don't know about SBBR by now? Oh, wow, James. Well, SBBR is basically the boot requirement for the servers, the ARM servers. And so we have a bunch of ARM specifications combined with UEFI and SMBIOS and ACPI to come together and put down the requirements for server systems. And the licenses that we have traditionally been using is an ARM license. So we developed the spec draft in the ARM Server Advisory Committee. And then people in that group can contribute and ask for changes, right? And then by the end of the development, we release the spec as the SBBR versions and published as a non-confidential document. So that's the kind of the arrangement we have been doing. And in the previous discussions that I presented on EBBR at the Connect, we were thinking about using the same model, but based on a lot of the feedback from the community, we have changed the model for developing the EBBR. EBBR is the embedded-based boot requirements. So it's, in terms of the collection of standards and efforts, it's similar. We are kind of referencing a lot of the ARM specifications and some of the industry standards. So we're here to try to develop an interface that could help the embedded system to work with the operating systems. And Grant likely will come up on stage to describe some of the details. But I just wanted to mention that based on the feedback, we have changed the licenses for developing this specification. So now it's based on the Creative Commons copies of the licenses. And the contribution is a little bit different as well, because we have so many people in the embedded world, right? So basically, in this mechanism, anybody can contribute to this specification. And the specification is hosted in the GitHub, which Grant is going to talk about in more details. So the development of this specification is different from SBBR. And we are kind of looking at this as a new model for these kind of specifications moving forward. If this is successful, I think we have generated a lot of energy in the development in the last 6 months. And if this is successful, we may be looking at changing some of the other specifications following this model as well. So I just want to make this brief introduction, and Grant is going to give you a lot of details on what we have done in the past 6 months.
Thanks, Dong. So yes, as Dong said, we've been working on this EBBR specification. And the work on this has gone on for about 1.5 years now. We've had conversations with various people, but there's still a fair bit of misunderstanding or apprehension or a little bit worry about what exactly is it that we're trying to do. Are we trying to impose things on embedded developers that's going to make their life hard, or is absolutely of no bearing to what they do in their day-to-day work? So we'll start with a brief history of booting. In the server, desktop, laptop, general purpose market, it's characterized, this is not going to be a faithful, this is going to be history according to Grant, so there will be wrong things in here. But in general, many binary operating systems, end user installation of the operating system is expected. If horizontal integration, the hardware vendors do their stuff, they get it working with the operating systems. The operating system vendors worry about getting their OS ready, and they don't want to have to go into too much involvement with the hardware. Reality is, of course, a little bit messier than that, but this is in broad strokes. And there's just a combinatorial explosion of the number of different combinations that can be supported this way. The upshot of all this is that in that market, there has been huge economic incentives to make sure that the standards are there, make sure that the interoperability is there. In the embedded market, we really haven't had nearly as much of that. Different kinds of products have different requirements, but in general, we're talking about OSs built from source. In a lot of cases, we're talking about Linux built from source. We're talking about vertically integrated. We're talking about the OS image tied to the hardware. And And so interoperability, as developers, we still value that. We still want to use the same U-boot project, regardless of which device we're building. But there's not the economic incentive to do all of the extra work required to get interoperability. What ends up happening, we end up with custom boot flow, as I said, a little interoperability testing. And there's pain points that have come out of that we're trying to actually deal with. For the distros, SUSE, Red Hat, Fedora, Debian, for the other operating systems, this is unsupportable. This is just not something that they can do. And as these embedded devices become more and more capable and running software stacks that are far more aligned with the software stacks that are running on general purpose machines, it's useful to have distributions in this market. So for a Raspberry Pi, if you want to get Debian on it, it's not as simple as plugging a USB key in and having a Debian image come up. You have to prepare a Raspberry Pi specific image. Each single board computer behaves subtly different, and it becomes impossible to support all of this stuff generically. Again, there's the description of the hardware. That also tends to go with the OS images, and when you do that, well, now you're another reason why you have a different image for every single board. Upgrades are incredibly painful when you don't have a standard way or standard place. Like on the general purpose, we have the grub running in the pre-boot environment, which allows us to choose which kernel we're going to do, and the operating system then has control over those kernels. We don't have that facility in a lot of the embedded systems. And then we end up with a bunch of domain-specific behavior. So Android, the way that Android firmware has designed it's diverged from anything else that was going on. They designed something that fit their needs, and it's oriented around kind of the fast boot way of getting images up onto a platform. But that looks very different from most of the U-boot-based systems, and it looks different, again, from a lot of the Chrome OS devices. And then if you do need to run something in the pre-boot, you don't have the capability of doing that. You don't have an environment where you can write an application and rely on it. And the world isn't all Linux. I've talked a lot about Linux, but there's FreeBSD, there's Microsoft Windows, there's other operating environments that want to support these boards. And every single one of these has to go off and do their own thing. The Raspberry Pi example, Microsoft supports Windows on the Raspberry Pi. They went and did completely different firmware to get that working from the firmware that's there to support Linux. So in firmware, exciting, which is all the work that you have to do to make it go, exciting is not a feature, and we want to get rid of that. We think these are solvable problems. In fact, we know that they're solvable problems because we're starting to do something about it now. There's no technical barriers to boot standardization. On the embedded platforms, yes, we've got a lot of variation, but there's no technical reason for doing that aside from slightly different destinations of where you might be storing images, where you might be retrieving your images. But the mechanisms, the commands, the way that you should do that, there's not a whole lot of reason for variance there. It's not just a distro problem. I talked about the Linux distros. The value of this isn't just for them. It's not merely about the distros being able to say, I support these 10 single board embedded computers that happen to be out there because they have a common software stack. It becomes useful for the vertically integrated markets because you no longer have to spend a bunch of engineering fiddling around with minor changes between single board computers. It becomes easier to integrate, it becomes easier to bring in standard features that, especially with IoT devices, are becoming more and more important. One of the big ones, of course, being secure boot. In the general purpose market, an awful lot of thought and engineering has gone into how do we implement secure boot, how do we support secure boot systems with Linux, what is the root of trust, what is the management model for handling all of those. There has not been anywhere near the same level of thought done for embedded systems. We can make use of the same thought processes adapted for embedded, but rather than trying to go off and do something new, there's the opportunity to adopt what has already been done. I want to stop duplicating the same work. That's the whole idea behind EBBR, is to start putting some specifications, some documents out there that are implementable with the upstream software that we have right now, and that gives some guidance on what hardware vendors should be doing when they're building their products. I threw a case study in here, just if you didn't believe me that this matters for the vertically integrated market. One of the things that came in on the thought for how EBBR was designed was cable set-top boxes, where the vendor they have a large deployment of set-top boxes of multiple different hardware variants, and they have a particular workflow that they need to, or there's a particular management flow that they need to do of getting code onto the box to do maintenance in the pre-boot environment before they boot their OS image. There's no storage on the box. It's entirely managed remotely. They had a whole bunch of pain with their hardware vendors that were providing different boxes into this ecosystem, and then they had to go do a whole bunch of custom work for each and every box. For them, going to a standard API that they could write applications to in the pre-boot environment allowed them to do the management cycle that they need, the upgrade cycles that they need, without doing it on a per box basis. And it gave them something to give to the hardware vendors of a specification of, if you do it this way, then we will accept your box. So now when you try to take on the problem of standardizing the boot flow in the embedded market, it's really easy to fall into boil the ocean and try to do everything. I mean, just taking a look at a survey of the embedded firmware projects that are out there, U-boot is the vast majority of traditional embedded Linux platforms are using U-boot. And then all of the Android things, or most of the Android devices, are using little kernel or something that looks like it. Chrome OS has their own core boot. They decided that they wanted a different security flow, and they have a different set of firmware there. And then there's some embedded devices that are using Tiano core. And then there's the related projects of trusted firmware, Opti, and some proprietary pieces in there. We needed to decide a place to start. And so we decided that the best place to start was to work on the market that looked closest to what we already had in the general purpose market. So in the general purpose, by and large, the hardware design has shifted over away from BIOS towards the UEFI interfaces. This is something that we can align with. And in the software stack, all of the OS stack looks very much like what it does on the general purpose when we're talking about the distributions. It makes sense that that's a starting point. We could quibble and we could have conversations about, well, why didn't we go and do Android first? Because there's a whole lot more Android devices. Android is not out of frame on this, but we decided that U-boot was the great place to start because we had an ecosystem that we could work with. And we wanted to start with achievable goals. Plus the single board computers that we're talking about, like a bunch of the 96 Raspberry Pi, all of the variants of the Pi, and a lot of industrial embedded boards are already working with U-boot. So as Don was said, yeah, EBBR is a specification, but our goal here is also not to create just yet another specification that is in the sea of things that people have to pay attention to. This is more of a platform requirements document. It's very similar to what Microsoft does for Windows hardware requirements. It is a survey of these are the things that you should adhere to, but it points to other specifications, and it only weighs in on technical detail when either there isn't a place to put that in another specification, or the other specification is insufficient at this moment, in which case we want to get things back in there. It is intended to be a useful document that our distro partners can say, if you line up with this specification, then we will support you as a platform. And then they can add additional requirements on that. But this is a shared document where, because the distros have all been participating in this, there's a shared agreement on what is needed. And we really wanted this to be an open process. As Don already talked about, we're doing this differently from how specifications in ARM have been done in the past. In the past, we have done, we've collected feedback from as many places as possible, but when it comes to writing the spec, ARM holds the pen. In this case, because there's an ecosystem that we want to be involved with directly, that's the embedded Linux ecosystem, right from day one, or sorry, when we met about this, I think it was 9 months ago when we made the decision to switch over, we realized that that process doesn't really work very well because we weren't getting the engagement. So instead, we switched over and we went radically the other way. So instead of proprietary license, we now use Creative Commons license. In fact, we're using a by attribution share alike license. So anyone who wants to participate, in fact, if someone wants to take EBBR and fork it for another purpose, that's fine. We're happy for that. We just see the value of having the openness. The drafts are in GitHub. We're using restructured text for the markup. We're using a mailing list, using a DCO contribution process. Anyone can participate. It should be very familiar to anyone on an open source project. And then finally, which is also new for ARM, is that this is architecture independent specification. We are not requiring this to only be for ARM platforms. Right now we're managing it. We will accept contributions from anywhere. We've had interest and involvement from some other non-ARM architectures. None of that stuff is actually in the spec yet, but those conversations are ongoing. It's also implementation independent. So as much as this process has been about U-boot, the intent is that it's a specification that anyone can implement with any firmware project. Because we've adopted the UEFI ABI as a baseline, Tiano Core EDK2 automatically is one of the supported firmware projects. U-boot, on the other hand, has not had UEFI support, and there has been quite a bit of work over the last 2 years. Alexander Graf over here has been involved in an awful lot of that work, where U-boot has grown, UEFI ABI for the boot time and runtime services have been added to U-boot. And there's been a fair bit of involvement and support from the U-boot maintainers on this effort, so that this is the direction that U-boot is going. They're going to adhere to the UEFI standard. So one of the biggest question that the question I'm asked most frequently about EBBR is, why are you forcing me off U-boot? We're not. That is not the intent here. UEFI is a specification. It is not a firmware project. Tiano Core is the firmware project. It has its own things. People have very strong feelings about Tiano Core. But U-boot can very easily implement the UEFI ABI, and it's well on the way to implementing what is needed. All the things that are needed to boot and install a regular Linux distro is already there in U-boot. We've added some architectural guidance to EBBR, so some like SBBR, it requires PSCI, for example, on AH64. We explicitly intend for EBBR to be a superset of systems for what SBBR describes. So SBSA, SBBR describe ARM server systems. It's quite constrained. It is an enterprise software ecosystem. By definition, every SBSA, SBBR enterprise system also matches the definition of EBBR, because EBBR is looser on the definitions because it takes into account embedded. We don't want to create two separate standards where embedded does something different from the general purpose just for whatever reason, for no real good reason. It also takes into account embedded system constraints. So one of the painful things on embedded systems is there's often only one storage device. Well, if you've only got one storage device and you are trying to use runtime services, or sorry, if your firmware image and your OS image come off that same storage device, you need to make sure that the OS install doesn't, or the OS operations don't go and overwrite your firmware. So EBBR comments on how that should be handled and how the firmware should be designed and the OS constraints. It also becomes difficult if you've got variable storage. If your variables are stored on your eMMC and Linux is running off of the eMMC and Linux owns the eMMC, runtime service is not going to be able to write variable updates. to that. So we're accounting for things like that and working out what the requirements are going to be to support the embedded platforms. As I said, standard open source project. All the details are there. The slides are going to be on the website, so you can find that. There is a committee. It is a very it's an ad hoc committee. We did not put a whole lot of process in here. We're relying on the contribution process, and the people who have come along have been quite engaged. If we, as the project matures, if we need more structure, we will add it. But for right now, it's the active and interested participants get to vote on when we release versions of the spec. Right now, it's at version 0.6. It's a pre-release. We want to get a version 0.7 out in the next few weeks. We're seeking feedback at ELCE and plumbers through some presentations, demos, and face-to-face conversations. The intent is to release 1.0 for early December. Once we have 1.0 is going to cover the basic boot interfaces. Once we get to 1. Past, oh yeah, so it's we'll cover ARX32 and ARX64, basic UEFI ABI. We specify hardware description must come from the platform. So you can choose DT, device tree, you can choose ACPI, one of the two, doesn't matter, but firmware must provide it. It's not something that the OS would be providing in normal usage. Guidance on shared storage, PSCI, runtime services guidance, and where we put exceptions to the UEFI spec because the U-Boot project is not yet up to that level, or we're looking for changes to the UEFI spec to better support it, which Peter Jones back here is smiling because he's already put one of those changes in. After 1.0, we'll start looking at the features that really are going to be needed, secure boot, capsule updates, embedded use cases like AB updates, pre-boot requirements, better compliance with the UEFI spec, being tighter, dealing with feedback, normal stuff. None of this should be surprising. And we're looking for non-Linux representation. Most of the people in the room are Linux right now. We've got one person from FreeBSD who's shown up and is interested, and hearing interest from other places. With that, thank you very much. There is a demo of some platforms that are soon to be EBBR compliant as we work out the last few bugs, and that's going to be demonstrated on Friday. Questions? Dave? How well are the SoC vendors for EBBR? We have 2 SoC vendors. We really need more because these are requirements that are going to affect what they do. Other questions? We'll go here first.
Do you have to be a Linaro member to participate?
Do you have to be a Linaro member to participate? No, you do not need to be a Linaro member. ARM is, like, well, I work for ARM, I'm running the spec, so I guess Don works for ARM, we own the spec. But we're doing an open process. You don't need to be a Linaro member. You don't need to have an NDA with ARM. You don't have to add any of that. Anyone is welcome to join the mailing list and join the weekly calls. And in fact, the details of that, if you go to the GitHub project, you'll find the details of all of that. So for the recording, Dave says that Linaro fully supports EBBR. And Rico, you had...
So a lot of the problems I've had with booting various SPCs when the firmware embeds the device tree is that the device tree is changing all the time in the kernel.
Yes.
So how are we going to deal with the fact that the device trees evolve and the kernels remain incompatible with different versions of device trees?
So we used to get away with that. Device tree support is maturing. More and more is becoming apparent that if you've got firmware that's shipping a device tree, kernel engineers have to, the authors of device tree bindings have to be aware of that and not make incompatible changes. Rob is going to have comments on that.
We need more complaining when that happens.
Yeah. Once there's boards that are shipped, firmware that's shipped with device trees in it, if it boots a mainline kernel and a change goes in that breaks booting, that's to be treated as a bug, and we fix it.
So at the last Connect, Alex complained some about that, and with new DTs not working with old kernels, and we fixed some of those issues since then to hopefully make that less common.
So, and I'm sadly going to have to cut off questions at this point because I've got a big red flashing negative number in front of me. So thank you very much.